Welcome, everybody. Thanks for coming today. My name is Hayden Blauzvern. This is Eve Martin-Jones, and we work at Google on open source security. Today, we'll be talking about our new publicly available dataset for the Sigstore ecosystem for researchers and interested individuals to learn more about Sigstore trends. We'll also talk to you about some trends and insights that we've gleaned from the dataset to inspire you to craft your own queries to learn more. For those who aren't familiar with Sigstore and the Rekor transparency log, we'll give a brief overview. We'll go into a bit of detail on our data pipeline, and then we'll jump into trends and insights. We have a bunch of really exciting charts and metrics to share. We'll provide some information about how you can access the dataset and what's next for the project. Alrighty, let's jump right in with a quick high-level overview of Sigstore and our transparency log Rekor. There is a need for trusted artifacts and artifact metadata throughout the software supply chain. To trust artifacts, we need integrity and authenticity. This is what signatures provide. Signatures are a critical component to securing software artifacts so that we know that the artifacts we use were generated by who we expect and trust. Signing isn't a new concept. Even some package registries like Maven Central have supported signed artifacts. However, we've seen low adoption of signatures in open source. Why is that? One of the most significant challenges is key management. How do you securely store key material? How do you respond to compromise of key material? Open source developers don't want to manage their own keys. User experience challenges are another barrier. PGP and its tooling is cumbersome. Signatures are not supported widely by registries. I mentioned Maven Central, which supports PGP signatures, and while PyPI did as well, they removed support for PGP after finding that most signatures were unverifiable for various reasons. Finally, developers don't prioritize security, and we believe they shouldn't have to. Signing should be as straightforward and ideally as invisible as possible. This is where Sigstore comes in. Sigstore provides tooling and services to enable signing without key management and adds auditability and discoverability for trusted artifacts. Sigstore signatures are associated with identities, such as workload identities from CI/CD workflows, to remove the need to manage keys, and signatures are published to a transparency log for auditability. This diagram is a 10,000-foot view of Sigstore's architecture. For this talk, we'll be primarily focused on the transparency log Rekor. For a really quick high-level overview into signing, a client will generate an ephemeral signing key and request a certificate for that key and identity, like an email or a GitHub Actions workflow. The client will sign an artifact and publish the artifact digest, signature, and certificate to Rekor, and a client can also use a self-managed signing key to sign artifacts if preferred. Again, Rekor's purpose is to provide discoverability and auditability of signatures. Artifact producers or verifiers monitor the log for their identities, and transparency logs are also designed to be append-only and tamper-evident so that log operators or malicious actors cannot hide or delete signatures. And this also, of course, makes Rekor a great source for a lot of data to learn more about supply chain security.
Let's have a look behind the scenes at how the ingestion pipeline maintains the Rekor BigQuery dataset. The pipeline is run and maintained by the deps.dev team. If you're not familiar with it, deps.dev is a service developed and hosted by Google to help developers better understand the structure, construction, and security of open source software. We collect and analyze data about millions of open source packages from across ecosystems like NPM, Go, and Maven. Deps.dev maintains a feeder which regularly polls the Rekor log for the latest log entry index. The feeder then pushes a bunch of messages to the ingester, telling it all about the new log entries that it needs to fetch. The ingester goes through and downloads each of these logs from the Rekor API. It stores the raw API response in Google Cloud Storage to allow for reprocessing in the future. And then it extracts the information we want to include in our dataset and notifies a syncer backend that a new set of logs need to be pushed to BigQuery. Overall, this works quite well, but there are a couple of challenges with running this pipeline. Firstly, the Rekor API rate limits introduce a bottleneck into how fast we can sync data from upstream. That's generally okay, but as more and more people write to the Rekor log, it'll become harder and harder for us to keep up. Luckily, that's solved by Sigstore's upcoming infrastructure update with Rekor v2, which offers a more easily scalable read path. You can read more about Rekor v2 on Sigstore's blog. This is also the reason that we store the raw API responses in GCS, so that if we need to reprocess the data to extract more information, or because of a bug in the pipeline, we can do so without having to use up upstream rate limit quota. Secondly, the Rekor log is over 1.5 terabytes of data. That's a lot to keep track of. Luckily, the resources that deps.dev is built on, like cloud storage and BigQuery, are very scalable, so it's okay for now. But that is something for us to keep an eye on as the log continues to grow. Now that you're familiar with Sigstore and the ingestion pipeline, we can jump into some of our favorite insights from the dataset. These queries are just a sample of what the dataset offers, and we want these queries and insights to inspire further research into trends in the ecosystem. Let's start with a simple query. How many entries are uploaded each day? For each of these queries, we'll be highlighting key parts of the query. So even if you're not familiar with SQL or BigQuery, you'll understand what the query is doing. Here we're using the entries table, which contains all Rekor entries and their upload time. We'll join this query result with data from the identities table, which contains certificates and keys stored by Rekor. The entry UUID is the common column between all of the tables that we provide, so you can easily join results. Here's a chart of the query result. You can see that Sigstore usage has increased more rapidly over the last year. We've also charted the number of entries each day. You can see very early on there was a significant spike, probably when we were running tests. Over the last few months, we've seen a large uptick in traffic and an increase in entries uploaded per day. We'd like to highlight a few key adopters of Sigstore to see if adoption led to an increase in entries. Around the announcement of NPM adding support for Sigstore sign source of provenance, we can see a spike in entry uploads. After the announcement of the GA release of Sigstore sign GitHub artifact attestations, we also see some increase. For PyPI's announcement of trusted publishing, there isn't a clear immediate increase. That makes sense though. We're seeing over 100,000 uploads a day. So even if a large percentage of PyPI adopted trusted publishing, we wouldn't really expect to see a spike here. And that little downward trend in late 2024 corresponds to the holidays. You'll also see a large spike that starts late last month and this month that corresponds to an uptick in traffic. And we'd encourage researchers to dive more deeply into the dataset and maybe research the correlation between entry counts and major adoption announcements. Let's also take a look at entry counts grouped by OpenID Connect provider. Each full CO certificate contains a set of extensions that represent various properties of the signer and build and source environment. In this query, we extract the OpenID Connect provider or issuer for the identity. This gets a human-readable string for the issuer by decoding and truncating the extension value. Here's a list of entry counts grouped by OpenID Connect provider. You can see that the majority of the signatures in the log are signed by GitHub Action workflow identities. Note that the total count here is less than the overall total count of entries, meaning that there are millions of entries that are signed with managed signing keys rather than using identities. What's really cool to see is how many of the top 15 OIDC providers are CI/CD. Here we can see GitHub Actions, GitLab CI, BuildKite, and CodeFresh. Some of these other issuers may be part of automated workflows as well, and the issued identities could be service accounts or workload identities.
Let's drill down a bit more. Here we query for the number of signatures generated by a source repository owner, that is an entity that owns the source code from a build, such as a GitHub organization or GitLab namespace. We'll group not only by source repository owner, but also by month, so we can look at how many entries are published each month. Like with the previous query, we use a specific Fulcio extension now that represents the source repository owner, and we'll group signatures by certificate creation time truncated to the month. Let's take a look at last year. These are the top 10 source repository owners per month, and we can see here that ChainGuard Images, the ChainGuard Images org, has been publishing a lot of entries. So if we filter out ChainGuard, we can see some of the other top Sigstore signers. These include Cilium and Isovalent, HPE's Cloud Data Services org, Sigstore's own org, and a few GitLab namespaces. Now, let's take a look at the number of distinct source repository owners per month to see if we see growth over time. We'll add a distinct statement and group by month to get the count of distinct repository owners per month. Here we see the graphed results with a count of distinct source repository owners each month, and as we guessed, overall we see growth over time, showing that more and more projects are onboarding to CI-based signing workflows. Now, you might see a drop sometimes, a drop month over month, like in early 2024, and that just means that there were fewer distinct source repository owners generating signatures that month. All right, let's switch topics a little bit. So let's say you have a particular artifact that you'd like to know if it's been signed. We can do that with this data set. We'll use the index keys table. We'll be publishing some more documentation about this table, but to summarize, index keys contain parts of a parsed entry, such as an artifact, digest, or DISI payload hash. For this example, we'll search for a specific artifact digest. We can see in the results that this specific artifact was signed 387 times. And if you're curious what this is cosign's README. I know I've generated at least a few of these. Now, let's look at other queries that leverage the index keys to try to find instances of either keys or artifacts used across multiple entries. It's worth noting that with this query, you will need to do further investigation to figure out what the digest is that's referred to in the result. In a future iteration on this data set, we'll be looking at adding additional columns to other tables to help distinguish between the various index key categories. So we'll join two tables together. Index keys provides a digest of either an artifact hash, a public key, or the contents of an attestation, and entries provides the Rekor entries. We'll filter out identities like workload identities or emails, and then we'll group by index keys. So we can see here from this chart an instance of an index key referenced in over 5 million entries. So keep this in mind, and we'll come back to this index key in a moment to try to figure out what this digest is referring to. Looking more into these results, we wanted to see what artifacts had been signed repeatedly where there's an associated signing identity. In order to find this, we join the identities table, which will give us the signer's identity. So in our results, the 24th row is the first example of an identity associated with some signed artifact. The reason we see this identity used so many times is that this identity is part of Sigstore's conformance test suite, which generates public, untrusted, reusable identity tokens for client testing workflows. We took a guess that this digest is probably one of the artifacts that is signed repeatedly during a conformance test suite run. And to no surprise, this is true. This digest is for one of the artifacts that is signed repeatedly, a.text. All right, let's revisit the index key referenced 5 million times. So we'll reuse the query for searching for a specific digest, and we'll filter using the digest from the first row. Let's see if we can find out more about this digest and figure out what this is exactly referring to. This view is from search.sigstore.dev, which is a front end for looking up entries by ID or index. We can see that the index key is a part of an entry for a signed attestation. Looking at this attestation, this appears to be from someone's Tecton pipeline. However, there's not a subject value in this attestation, so we know that the digest isn't the subject of an attestation. I mentioned previously that index keys can refer to many different types of values, including attestation subjects, artifact hashes, or digests of public keys. And in this case, when we dig in a little bit more and we take the SHA-256 digest of the public key, we end up finding that it matches this digest that occurred 5 million times. So what does this mean? It means that someone used a signing key 5 million times to sign various artifacts and record them to Rekor. So this was just one insight that we dug a bit more into, and we'd encourage researchers to poke around the data set to try to find more insights and trends. So for the last query that we want to show off, we wanted to try to join across multiple data sets. And so here we'll join Rekor's data set with a table from the deps.dev data set. There's a lot going on in this query, so let's dig in. Our goal with this query is to learn more about an artifact. We'll join entries from Rekor with packages ingested by the deps.dev pipeline. We can join Rekor tables with the entry UUID, and we'll use the source repository as the common value between the identities table and one of the deps.dev tables, the package versions table. We'll note that we've added an arbitrary limit to filter results. This is an expensive query, and we ran into errors for exceeding memory resources. So for any researchers who want to explore these data sets more, we'd encourage more filtering. For the deps.dev table, we chose the package versions table to join against, since this table contains attestations. We've left a link here if you'd like to explore other deps.dev datasets, which could be joined for additional insights. It's a bit tricky to visualize the results of this query, so what you'll see here is a JSON representation of a subset from one row of the result. You can see here in the first box the Rekor entry, the next box the deps.dev data, an artifact and its verified provenance, and finally you can see the value from the certificate that was used to join everything together.
These insights are just scratching the surface of what this dataset can provide. We'd like you all to use this dataset as well to learn more about Sigstore signed artifacts. To access the BigQuery dataset, you'll need a Google Cloud Platform account. This was the simplest way for us to provide the data, as it wouldn't be feasible to frequently distribute and update a 100 gigabyte file. Queries will incur a minor cost. If you're a researcher, we've included a link where you can request cloud credits to pay for queries. You can access our dataset via the marketplace listing we've linked on the right. As you've seen in our examples, we have a number of tables. The entries table contains Rekor entry metadata, such as log indices, the entry type like hashed record, and the integration time. The identities table contains information about the signature verifier, like certificates and keys. The index keys table contains a many-to-many mapping of entry IDs to the index keys from Rekor's search index, such as artifact hashes. Finally, the artifacts table contains data from in-toto attestations stored by Rekor. Note that we will be revisiting the contents of this table in the future, since Rekor has deprecated support for attestation storage. To get the schema, we've included a query. If you have more questions about the schema, please feel free to reach out. If you're interested in visualizing the data, all of our charts today were generated with Looker Studio. Well, that about does it. We've got a few updates that we plan to make in the coming months. First of all, as you start using this dataset, if you have any questions or feedback, you can reach us over email. With some early testing of the table, we've noticed that many simple queries require a full table scan, which can become costly over time. So we're going to look into adding more indices. We'll also look into adding more named columns to simplify queries. And finally, as we mentioned, we'll be revisiting the artifacts table. Thanks for coming to our talk. Any questions?
Super cool. When you go mining into any data set, interesting things pops out. Did you see any indications of abuse?
That's a good question. We didn't see anything. Now, one thing I'll mention here is that Rekor is quite permissive in what you can upload to it. So you can actually see some examples, for example, of issuers for certificates that don't really make sense, and that's because somebody's uploaded certificates from an issuer that they manage. We didn't see any examples, especially widespread, of any sort of abuse, though.